how sensitive are these and what can we have to fade this in? So the take home here is that our intensity discrimination is poor for smell and taste. So what do I mean by that? If you are tasting a certain amount of sugar and you want to taste more sugar, you need to go up 30% to detect that there was more. That's not very accurate at all, okay? Not very precise. The sensitivity is very good for smell and kind of in the middle for taste. So how am I describing those? So let's name things that you've heard before. So carbon dioxide, can we smell it? No. Our odor detection for carbon dioxide is 74,000 parts per million. That's how you measure gas, right? So how many of those are in a million molecules in the gas? Well, with climate change, you might have heard that we passed 400 parts per million. So we're like 415 as of yesterday. So we can't smell it. Unfortunately, we die at 50,000 parts per million. It would have been nice if we evolved to smell it before we died, you know, if our head was in a bag or something, but we're never realistically gonna get that high. Maybe in a bag, but okay. Anyway, so as you go down, as things become more and more deleterious to us, our sensitivity increases. Gasoline, you get that drop of gasoline on your sleeve and you can smell it all day. Our threshold there is 0.3 parts per million. Kerosene, acetic acid, hydrogen sulfide is 0.0005 parts per million, okay? Now, I'm gonna compare that to taste, and since taste is in micromoles per liter, I just did a conversion here so you can see. So for taste, what about glucose? Glucose, our threshold is 80,000 micromoles per liter. Now that might seem odd at first because glucose is very important to us, and this means we cannot taste it well. But we do not want to have a drop of a Big Mac, you know, juice and be like, oh, I'm done, we're got enough, or I don't know, I guess it would be bread, right, a little piece of bread. You need a lot of it in volume. So your detection of that is down, so your body wants more, okay? Same with sucrose. MSG is about 10,000. Sodium chloride becomes higher sensitivity, so we don't put, you know, volume-wise that much salt in our body. We don't need that much, 2,000. Then you get to the bad things. Hydrochloric acid, 100 micromoles per liter. And then you get down to strychnine. If you ever saw like old Bond films, this was used as a poison, 1.6 micromoles per liter. So the smell threshold you see is orders of magnitude, or can be orders of magnitude more sensitive than taste threshold, okay? And again, I used to have an action figure here. I think I mentioned this in my pH lecture. One of the things that I don't think people do a lot is the Western diet, we have way too much sodium. So one of the ways, the biohacks you can do for your patients is you can mix sodium salt and potassium salt. And once you get to about a 1-to-1 ratio is usually where people can't tell the difference. When you go beyond that, if you have like 80% potassium chloride, and 20% sodium, people can tell the difference. So potassium chloride is Dash salt, that's the name brand, and it tastes a little different, not as good. But at a 1-to-1 ratio in, you know, Casa de Arbor, we get less sodium using that mix. Okay. I will say the other Dr. Arbor likes her Norma Morton salt, which is iodine fortified, which there is a deficiency in, so make sure you get your iodine.